Hi, I'm Mary, and this is another magical math moment. In this video, we're going to be looking at graphing sinusoidal functions. So we're just going to focus on sine and cosine in this video. And we're just looking at the parent function, and we're not going to get too much into it. There will be other videos that will talk a little bit more about different transformations of these functions. So this is kind of just the basic, how you graph sine theta and cosine theta as functions. So to be able to do that, we're going to need some points. To get points, we can use the unit circle as a point of reference. See what I did there? Anyway, you all know the unit circle starts at 0 and goes around counterclockwise. So if I'm at 0 here, I go up to pi over 2, to pi, over to 3 pi over 2, and then once I'm back over here, this is 2 pi. So we know unit circle has a radius of 1. That means all of these distances out from the center are a length of 1. This point would have coordinates 1, 0. Up here, 0, 1. Over here, negative 1, 0. And then down here, 0, negative 1. And as I go around, the values will repeat. So when you look at your sine and cosine graphs, you're going to see cyclical functions. So they have got a repeating pattern that kind of goes as they go on in time. So we know already too that x, y can be written as cosine theta, sine theta. So we're going to use what we know about that and these values to help fill in a table of values for the function y equals sine theta. Trig functions are a little bit different because when we're graphing them, we're not using x and y, we're using the angle measure theta and then the y value, which represents the function value. So if I think about sine, I know those are y values on the unit circle. If I look at 0 degrees, or just 0 here, 0 radians, my y value is 0. As I go around the circle, when I'm at pi over 2, the y value is 1. Once I make my way over to pi, the y value is 0. Once I go down here to 3 pi over 2, my y value is negative 1. Once I'm back here at 2 pi, my y value is 0. As you can see, there's a pattern that forms with these different values of the function. The maximum y value will be 1. The minimum will be negative 1. As I go across here, along what normally is my x-axis, this is really going to be my theta axis. So I'm looking at the angle measure 0, pi over 2, pi, 3 pi over 2, and finally 2 pi. So when I'm graphing my function, I will start at 0, 0. That's right here in the middle. Then at pi over 2, I go up to 1. At pi, I am back down at 0. At 3 pi over 2, I am at negative 1. And then at 2 pi, I am back to 0. So as you try to graph this, it's gonna look, ooh, that wasn't so good. Something like this. Now, normally this would be symmetric. It would be really pretty, right? But consider human error here as I have made my little tick marks for my angle measures. So this is what a sine curve looks like. Note that when you're graphing this, there are 1, 2, 3, 4, 5 points that you'll be plotting along what is normally your x-axis. Another thing to kind of keep in mind here is this, that the x-axis in this serves as what we call the midline. So it kind of cuts through the middle of the function. That means half is on top of the midline, half is down below. We can also talk about something called the amplitude or height. In a regular sine function, the amplitude is 1, and we use the parameter a for that. So what's nice about this, as we continue around the circle and we have coterminal angles to all of our original ones here, this pattern's going to repeat. So it would kind of continue on and on forever to the right as also back to the left, okay? Let's examine cosine and see what's going on. In this example, theta will still be along our x-axis, and the y value for the function cosine theta will come from the unit circle. When our angle is 0, cosine is 1. So the y value we will plot is 1. When I'm at pi over 2, the x value is 0. At pi, the x value is -1. At 3 pi over 2, the x value is 0. When I'm back up here at 2 pi, the x value again is 1. So as I think about what this is going to look like over here, I know that I am at 0 here. Ooh, sorry about that. Pi over 2, pi, 3 pi over 2, and then finally 2 pi over here. Again, 1 and -1 are our max and min values respectively. So this one's starting up at 0, 1. At pi over 2, I'm over here on the x-axis. Pi -1 is a point. 3 pi over 2, 0, and then finally 2 pi. So if I try to draw my curve, oh gosh, it looks something like that. It's kind of silly looking, right? So it always reminds me of like some kind of decorative bowl or something. So again, if we look at the height of this thing, that's our amplitude. In this case, it's 1. And remember, in the middle here, we have a midline. That will help you when you start moving these things up and down. Similar to the sine curve, it's going to kind of continue forever in both directions. And you've probably kind of suspected as you look at this that they're very similar in that if you take the sine curve and move it over like so, it mimics the you can't see what I'm doing. Let me show you this again. If we start here, where we have our y-axis lined up, and I shift this sine curve over, look how the values mimic that of cosine. So cosine and sine are very similar in their shape. They're just basically transformed over by a difference of pi over 2. And I'll talk about that in later videos. This is just kind of an introduction as to where those points come from, because teachers don't always explain that to you. They just kind of say, these are the values at these angles. The values come from the unit circle, which you've already studied. So hopefully that makes a little bit more sense for you. If you like the video, please like, subscribe, and share so you can see more fun math content. And as always, I thank you for joining me, and I'll see you next time. Bye.